Hello students, my name is Kriti Mishra and we are studying social media analytics and data analytics. Executive code is BCM061 and we have seen many of the lectures in this topic. In the second unit, we are studying social media analytics regarding network. We are studying that how the network is going to, how we are going to analyze the network so that we can understand the social media and take a useful information from the particular data. A topic is type of connections in social media analytics. So there are many type of connections in social media analytics. One is user to user connection. Means what is user to user connection? Like friendship, for example, friends mention and tags which you people must have done on the Facebook or in the Instagram, Twitter, etc. Friendship, for example, friends and friends on Facebook, followers, for example, people follow different celebrities, different channels on the Twitter and Instagram, and mentions and tags that using @ they mention to particular celebrity or minister for any particular thing. Next is a direct connection. Direct connection is through comment and messages. So this type of connection in social media is called user to user connection. There are different type of connection. One is user to user connection. Next is user to content connection. What is user to content connection? For example, when you like, share, tweet or give any reaction to the particular post, that is your, means you are the user and the particular content. So there is a relation between user to content. Your like, shares and retweet shows a connection between them. And next is comment and replies. Then viewing pattern. For example, video watch time. Through your viewing pattern or your watch time, we find, or the analyst find a pattern, try to find out a pattern, that in which pattern you are liking or you are commenting or you are reacting on a particular video, or for how much time you are watching a video. And click and link interaction. Your clicks and link interaction is also comes under user to content connection. Next is content to content connection. What is content to content connection? When there is a hashtag and keyword, trend and topic clustering, links and between posts. For example, quoted tweets and shared article. So these are the content to content connections. Next is influencer and community connection. Key opinion leaders and influencers. Is influencer and community, means what is influencer? That particular person is connected to large group of people. That particular person is called influencer. So the influencer and community connection means particular influencer is connected to any particular or one or more communities through different medium. So key opinion leaders and influencer. Next is community detection. For example, groups, cluster of users. Virality and information diffusion pattern, which we see in the influencer and community connection. Next, how connections are analyzed. So there are many ways to analyze the connection. One is network analysis. Use graph to visualize user relationship, which we have seen how we define, how we represent user using a node or vertex, and if we should have to show the connection between them, we use edge to show the connection between them. So network analysis is a way to connect, use graphs to visualize user relationship, for example, social network graph. Next is the engagement matrices. Next is engagement matrices. So what is engagement matrices? The measure interactions, like what are the interaction, like, share, comment, subscription, etc. These are the engagement matrices, that how you are engaged to the particular video, audio or any data. Next is sentiment analysis. What is sentiment analysis? Through the by understanding your likes, dislikes, comment. If you are if you like particular video, that means that is positive. If you don't like that particular video, you dislike the particular video, that is your negative sentiment towards that particular video. or if you do not do anything like or dislike, that is neutral. So in the context of this connection analysis, sentiment analysis is used, in which we evaluate what positive, negative and neutral emotions through the connection, through that particular node, vertex or user. So that is sentiment analysis. And then influencer detection. So influencer detection is identifying key user driving discussion. That is influencer detection. Next is topic modeling. What is topic modeling? That group connected content based on theme. Group connected content based on theme is topic modeling. So these are the how connections are analyzed. These are the various ways to analyze the particular activity on the social media. Next, influencer identification. Influencer identification, hashtag co-occurrence analysis, fake news and misinformation detection, community detection in social network, sentiment spread analysis, click stream analysis for engagement measures, and bot and spam detection. These are the applications of link analysis. Next, the next topic is random graph. So what do you mean by random? Random is when something is randomly occur, means something that is not fixed. You can randomly choose or opt any particular option. So random graph, in the context of randomness in the graph, that a random graph is a graph in which properties such as number of graph vertices, graph edges and connection between them are determined in some random way. The graphs illustrated above are random graphs on 10 vertices with edge possibility distributed uniformly 0 or 1. Means there is connection between these two nodes. This is 1. There is no connection between this. This is 0. This to this node. Means we have 10 vertices and these vertices are connected randomly. So this is a random graph. Next, random graph and network evolution, in which random graph and network evolution are crucial concept in the field of social, text and media analytics. They provide a mathematical framework and understand the structure and dynamics of complex network. Key concept and principles. What are the key concept? In random graphs, graphs are mathematical model that represent a set of object vertices and nodes connected by link edges. For example, the Arrows and Rennie model is a popular method. This model is a popular method for generating random graphs, where each pair of node is connected by an edge with certain probability. So key characteristic of random graph include degree distribution, the number of edge connected to each node, and the cluster coefficient, the degree to which node clusters are together. Next, on which basis the random graph is connected. So a random graph is a graph made by connecting vertices nodes randomly, and this means the connection between the nodes are determined randomly based on the certain rules or probabilities. So random graphs are used to study networks where the exact connection are not known beforehand, but follow them some random patterns. So what are their patterns, on which basis they are connected? So one basis is the probability. Probability is a basis through which the graph can be connected. There will be some probability of connection or probability of disconnection. So edge between vertices are created based on a probability. For example, each pair of vertices might have an edge with probability P. There is probability P, means probability lies between 0 and 1. So there will be edge. If there is a edge, that is 1. If there is no edge, that is 0. Then variety of model. There are different models for generating random graph. For generating variety of model, there are different models for generating random graph, such as Arrows and Rennie model, where each edge is included with a fixed probability, or the Arbester-Albert model, which generate a scale-free network. For example, what are the applications that random graph are used in network theory, biology, computer sciences, and social science to study the property of real-world network, like robustness, connectivity, and the spread of information or diseases. So these concepts are also used for the research work. Generating random graph. Random graphs are generated using various algorithms. The major challenge is to model randomness while preserving certain properties of real-world network. Following are the method for generating random graph. So random graph with G and comma P, and is the node, P is the probability. The most basic way to generate a random graph is by creating an Arrows-Rennie random graph G of NP, where n is the number of vertices, P is the probability of each edge being present. So what is the algorithm? Algorithm is the basic step to generate the random graph by creating this algorithm is initialize a graph with n vertices and no edge. Means first of all we will take different nodes with no edge between them. For each pair of vertices, generate a random number. For each pair of vertices, generate a random number. If the number is less than P, add an edge between the two vertices and repeat the process until all edges are evaluated. This is the random graph generation method using Arts and Rennie random graph generation method algorithm. So this is the example generating random graph. Here nodes 16 and 18, how they are connected, and this 12, 5, there are different nodes connected randomly with each other through the using probability method. So our next topic is network evaluation. Network evaluation plays a very important role in social media analytics. So we'll see how the network evolve over time. So initially, what are the network and things which we were using, and nowadays what all are things we are using. So network evaluation refer to the process by which network changes over time. The preferential attachment model is a common method for simulation network evaluation, where new node prefer to attach to existing node with a high degree, and this leads to the small world phenomena, where most nodes can be reached for every other node by a small number of steps. That is network evaluation. Next, typical problem and solutions. Analyzing the structure of random graph. To analyze the structure of random graph, we can calculate degree distribution and clustering coefficient. We can also identify communities, group of node, with more connections within the group that with the rest of the network, and network modifies recurring pattern of interconnections. Now, predicting the growth of network over time. So, to predict the growth of network over time, we can apply the preferential attachment model to predict the degree distribution node. We also simulate network evolution using agent-based model, where each node is represented by an agent that follow certain rules. What are the real world application examples? Real random graph and network evaluation have numerous applications in social network. For example, analyzing friendship network, prediction, information spread, text network. For example, analyzing co-occurrence network, predictive words association, and media network. For example, studying citation network, analyzing news networks. So these are the real world application and examples of network evaluation. Now, what are the advantages and disadvantages? While random graph and network provide powerful tools for modeling complex system and predicting network dynamics, they also have limitations. Their simplify assumptions may not capture all aspects of real world network. So, and analyzing large scale networks can be computationally intensive. So, what conclusion we find out? In conclusion, random graph network evaluation offers valuable insights into the structure and dynamics of complex network, social, text, and media analytics. They also hold great potential for further research and application in these fields. So, what we have studied? Network evaluation, random graph, and how these links are, and the types of connection in social media analytics. Different type like user to user connection, user to content connection, content to content connection, influential and community connection, and how these connections are analyzed, their applications. Then random graph, that how different vertices are connected on the basis of probability through 0 or 1. Erosion-Rennie algorithm model. So we'll see the next topic in the next video.